Hello, curious minds. Have you ever wondered just how many intelligent civilizations might be out there in the galaxy trying to make contact with us? What if I told you that there's a simple equation that could give us the answer? Today, we're diving into the Drake equation, a fascinating tool that could help us find out if we're truly alone in our galaxy, or just one of many advanced civilizations scattered across the stars. Imagine trying to estimate how many piano tuners live in a city. You might consider factors like the city's population, how many people own pianos, and how often pianos need tuning. The Drake equation, in a way, is like that, but instead of piano tuners, we're looking for alien civilizations across the vast expanse of the Milky Way galaxy. Developed by astronomer Frank Drake in 1961, the Drake equation is a probabilistic argument, a way to organize our ignorance about a complex issue. It breaks down the daunting question of finding intelligent life into smaller, more manageable pieces. By assigning values, even if they're educated guesses, to each piece of the equation, we can get a rough idea of the potential number of civilizations out there. The equation itself is surprisingly simple. N equals R star times F sub P times N sub E times F sub L times F sub I times F sub C times L. Don't let the letters intimidate you. We'll break down each one in the next section. Remember, each term in the equation represents a different factor that could influence the number of intelligent civilizations in our galaxy. The first term, R star, is the rate at which stars form in our galaxy. Think of it as the starting point, how many new stars are born each year in the Milky Way. Current estimates suggest around 1 to 3 stars form each year, giving us a solid foundation to begin our calculations. Next we have F sub P, the fraction of those stars that have planetary systems. With recent discoveries of exoplanets, planets outside our solar system, we know that planets are quite common. In fact, almost every star might have at least one planet orbiting it, so we assign a high value to FP, somewhere close to 1. Moving on, N sub E is the average number of planets per star system that could potentially support life. This is where we start to narrow things down. We're looking for planets in the habitable zone, where conditions might be just right for life as we know it. Based on current research, scientists estimate that each star system might have about 1 to 2 such planets. Then comes F sub L, the fraction of those planets where life actually arises. This is one of the more uncertain factors because so far, Earth is our only example. The value we assign here depends on our assumptions about how easily life can emerge from non-living matter. Some are optimistic, thinking life might be common, while others are more cautious. Next up is F sub I, the fraction of life-bearing planets where intelligent life evolves. Again, Earth is our only data point, so this factor is highly speculative. It raises profound questions. Is intelligence an inevitable outcome of evolution, or is it a rare fluke? After that, we have F sub C, the fraction of civilizations that develop the technology to communicate across space. This includes things like radio waves that could be detected by other civilizations. This term reflects the idea that not all intelligent life may be interested in or capable of communicating with us. Finally, there's L, the average length of time these civilizations can communicate. This is crucial. How long does a civilization last before it either destroys itself or loses the ability to communicate? The longer they last, the higher the chances we'll detect them. When you multiply all these factors together, you get N, the number of civilizations in our galaxy that we might be able to detect. Each term carries its own uncertainty, and tweaking any one of them can dramatically change the outcome. That's part of what makes the Drake equation so fascinating. It's both a tool and a conversation starter, helping us explore one of humanity's biggest questions. Are we alone in the universe? As you can see, the Drake equation covers a lot of ground, from the birth of stars to the longevity of civilizations. While we have increasingly accurate data for the first few terms, the later terms, like the likelihood of life arising and the lifespan of intelligent civilizations, are still shrouded in uncertainty. This is where the Drake equation becomes less of a precise calculator and more of a thought experiment. Depending on your assumptions about the values of each term, you can get wildly different results for N, the number of detectable civilizations. Some optimistic estimates suggest there could be dozens, if not hundreds, of civilizations in our galaxy alone. Others, more cautious, estimate that we might be the only ones broadcasting our presence in the Milky Way at this particular moment in time. The Drake equation, despite its inherent uncertainties, has been profoundly influential in the field of astrobiology and the search for extraterrestrial intelligence, or SETI. It serves as a constant reminder of the vastness of the cosmos and the possibilities it holds. Even if we never manage to pinpoint an exact number for N, the Drake equation has spurred scientific inquiry into each of its terms. We're learning more about the conditions necessary for life, the prevalence of planets around other stars, and the challenges of detecting signals across interstellar distances. The equation has also fueled our imaginations, inspiring countless science fiction stories, films, and television shows that explore the potential diversity of life and intelligence in the universe. The possibility of discovering another intelligent civilization is both exhilarating and daunting. What if, out there among the stars, other beings are contemplating the same cosmic questions as us? What if they've overcome challenges we're still grappling with or have insights into the universe we've yet to imagine? The discovery of even a single extraterrestrial civilization would revolutionize our understanding of our place in the cosmos. It would force us to confront the limitations of our own knowledge and the profound implications of not being alone in the universe. It's also worth considering that the search itself, whether or not it yields positive results, is expanding our technological capabilities and deepening our understanding of the universe we inhabit. So what do you think? Could there be countless intelligent civilizations out there waiting to be discovered? Or are we truly alone in the vastness of space? I'd love to hear your thoughts in the comments below. And if you enjoyed this dive into one of the universe's biggest mysteries, don't forget to like, subscribe, and hit that notification bell for more cosmic explorations. Until next time, keep looking up.